Hey everybody, welcome back with a new training course about one of the most important techniques in every lab, chromatography, which plays a very important and vital role in many fields, from chemistry and biology to pharmaceuticals and environmental science. And it's a powerful technique which allows us to separate, identify and quantify complex mixtures of compounds in the sample. Chromatography is a technique used to separate mixture of analytes into its individual forms or components. To get only the target analytes need to be analyzed to be easily identified and quantified. And you may have a confusion between chromatography and extraction, but extraction is the first phase. At the beginning, you need to extract target analytes from the matrix itself using two immiscible liquids such as water and organic solvents, and from them you will have two layers. One of these layers will carry our target analytes, and this mixture of target analytes in the solution will be transferred to the instrument to be separated or eluted by chromatography to get the specified target analytes or required analytes. So in the test sample which is the sample to be tested on the instrument after extraction. So in the test sample there is a mixture of analytes need to be separated to its individual forms or components to be able to identify and quantify the target analytes in this matrix. And to have this separation, mixture of analytes shall be distributed between two immiscible phases: stationary phase and mobile phase. Stationary phase, which is always composed of a solid or a layer of liquid adsorbed on a solid substrate, and mobile phase, which can be gas or liquid. Gas in case of instrument gas chromatography or GCMS, and also liquid such as UPLC or LC, liquid chromatography or LCMS. And finally, separation steps: how to separate mixture of analytes into its individual form or components. First, mixture of analytes will be placed into the mobile phase and they will be mixed together. And then mobile phase will carry the sample solution containing the mixture of analytes and move along the stationary phase. And in the stationary phase, each analyte will be adsorbed to the solid phase or stationary phase, but with different tendencies based on the attraction force between the analyte and the stationary phase. And the stronger attraction between the analyte and the stationary phase, that means the slower the movement of analyte, and that analyte will be eluted later. So this analyte will be absorbed for longer time on the stationary phase and will be eluted later. It will take longer time to be eluted or separated from the column or the stationary phase. And the analyte that bonds less strongly to the stationary phase will move faster, so it will be eluted first. As here in this graph, you will find that mobile phase will carry the sample solution containing the mixture of analytes and move along the stationary phase. And in the stationary phase, we have different analytes. Different analytes will be separated based on the attraction force between the analyte and the stationary phase. So this analyte will take longer time than this analyte. This analyte will be eluted first. And here you will find in the chromatogram, you will find that peaks eluted later and peaks eluted, that peak eluted first at specific retention time. Here the relation between intensity and retention time for each compound, the time for the compound to be eluted. So this time this compound eluted first, this after this is the second compound to be eluted, and then that compound takes longer time in the stationary phase to be eluted. That was the end of our lecture for today. Thank you and see you in the next lecture.